Welcome to the Electrical and Electronic Engineering Lecture Series. Your anchor person is Professor Michael Sindinechi. Our topic today is Module 042, Telecommunications Network Planning. Please follow me in the Engineering Lecture Series by subscribing to my YouTube channel at https://youtube.com/@Ndinechi C. Please like, share, and drop your comments in the comment section or reach out to me using my email addresses. You can also listen to related lectures on telecommunications, network planning, optimization, network models, regulations, and standard using the two links stated. You can also visit Ebony Educational Consult website for free lectures on electrical and electronic and some public lectures using www.ebonyeducationalconsult.com. There you will get more free lectures. Today, our topic is telecommunications network planning. What is telecoms network planning? We say that it is the process of designing, optimizing, and forecasting a telecommunication network's infrastructure and resources to meet current and future communication demands in an efficient, reliable, and cost-effective manner. It involves identifying user needs, analyzing existing infrastructure, estimating future traffic, and determining the optimal deployment of technologies, topologies, and equipment. Now, what are the objectives of a good telecommunication network planning? The core objectives of any telecom network planning must include: 1. Capacity planning. This capacity planning is to ensure that the network can handle current and future traffic volumes with acceptable level of congestion. That is, as you deploy your network and it is growing, you must plan for this growth for your system to be able to handle it. Second one is quality of service. Your objective must guarantee performance parameters such as latency, jitters. Of course, we know what jitters is and how it affects voice signals. So, it must improve the bandwidth, the quality of the bandwidth to ensure that the uptime meets some basic defined standards. When we talk of uptime, we talk of when the system is performing optimally. Then cost optimization. The objective, or one of the key objectives of any telecom network planning, must include how to minimize both capital expenditure and operational expenditure while still maintaining service quality. If your operational expenditure becomes so high, then you operate at a loss. And that is why some telecom companies, after operating for some years, die down or fizzle out because the cost of operating the system, outweighs the profit being made. The next objective is the scalability. Say that the planning design of the network must be in such a way so that it can grow or adapt easily as user demand or technology evolves. Coverage and accessibility. It must ensure network availability across all intended service areas, including remote and underserved regions. Of course, it has to support technology integration, must support current and emerging technologies like 5G, moving to 6G. It must support new technologies like Internet of Things, moving from coaxial cable to fiber optics, and so on and so forth within the same planning framework. Redundancy and reliability must incorporate backup paths and failover mechanisms to reduce the impact of faults and ensure high availability. Of course, it must adhere to regulatory compliance. In other words, it must align with national and international telecommunication regulations, policies, and standards. In one of our lectures here, we have treated the regulations and standards. So if you want to know more about telecoms regulations and standards, you can, go to my channel, Engineering Lectures Series channel, and look up lectures on telecommunication regulations, policies, and standards. Again, one of the core objectives include environmental and social considerations. So saying that your plan must be able to minimize the environmental footprint and consider social impacts such as digital inclusion and community development. So we are saying that typically the components of any good network, telecom network planning must include traffic forecasting. We will see that later. Topology design, we've looked at that when you talk about are you using star or mesh topology to reach out to your customers or to the users. Must include link budget, that is the complete analysis of signal losses between the receiver and the transmitter. Then it must include your transmission and switching plan, your numbering and addressing plans, the risk and failure analysis, and evolution and migration strategies. Because in future, the network will be migrating from one level to the other. So how will your system be able to accommodate new evolutions in telecommunications? So we now have stages in this planning. In endeavoring to meet the network requirements, the planning engineer must continually bear in mind the time scales within which he is operating. The plant and accommodation on which his plans depend are unlikely to be provided in a very short time. And when they are provided, they will last for at least another 20 to 30 years. So it is possible to distinguish broadly 4 different types of planning as follows. First one is strategic planning. The strategic plan is as important for the network as the business plan is for any business growth. It should chart the direction in which the network should move within the next 20 to 30 years and indicate signposts, options along the way, which as you meet them, you know you are in the right track. If you are not meeting them, you know that there is something wrong somewhere. So amongst the contents of this strategic plan should be one, estimate of the traffic to be carried at a number of base dates throughout the period at yearly intervals. It is also necessary to examine the likely telecommunications options throughout the planning period to determine whether new services will need to use the network and extent to which these services will be integrated into the network. Must include production of this section of the strategic plan, which will involve investigation into population movements over the planning over the period, the patterns of industrial activities, and likely changes in home, office, and factory communications. If you fail to plan for this, if all of a sudden there is upsurge in population, then you will start experiencing a lot of congestions in your system, which if you have not done adequate planning for that growth, your system becomes, very, very uncomfortable for your users, and they may have to migrate to or port to another telecommunication service providers. So you must study population movement while you plan for your long-term telecommunication rollout. A careful evaluation of new technology solutions likely to be available within the strategy plan period in terms of practicability, facilities which could be provided, and likely costs and cost trends. We've talked about operational costs, that if you don't have very good operational cost estimates, your business will collapse over a period of time. On the basis of the two above, a comprehensive technical and economic evaluation of the optimum networks to deal with traffic to be carried at various base dates must be stated. What we are saying here is that as you plan, you should be able to estimate what traffic you will be carrying out by this time next year in your network. That will help you to, integrate what growth you are looking for or looking up to in the next 20, 30 years. So, a generalized conclusion should therefore be made on the types of equipment which will be required throughout the planning period. Any significant network changes should be clearly brought out. Where a fundamental change to a network is proposed, the cost of transition must be examined and an implementation strategy laid down, which minimizes the cost penalty of the interworking and the interfacing requirements. Now, another stage in the strategic planning include long-term basic planning. In telecommunications, long-term planning is the systematic forecasting and development of network resources, technologies, capacity, and coverage to ensure the telecommunications system can meet anticipated future user needs, meet technology changes, and meet regulatory requirements and market demands. It usually refers to the strategic process of designing and preparing the telecommunications infrastructure and services to meet future demands over an extended period of typically between 15 to 25. What are the objectives of this long-term telecom network planning? One of the major objectives is to be able to forecast future demand. Like we said, you must be able to estimate growth in data traffic, user base, and service usage. You must be able to plan or forecast for emerging services. For instance, we are looking at future services 6G, Internet of Things, artificial intelligence-driven communications. If at the point of time these things come into effect and your telecom network cannot accommodate them, it will mean two things. Either you are thrown out of business or you start all over to reinvest into new technologies. So your long-term plan must be able to forecast these future demands. The next one is scalability. One of the core objectives is that your design infrastructure can be expanded or upgraded very easily so that it doesn't take you years or months to upgrade. If you tell your users that you are upgrading, before they wake up from sleep, you have upgraded. So it must be very easy and seamless for you to upgrade. You must also avoid bottlenecks and system overload in the future. You must see these things at the time you are planning your network, your telecoms network. Then, one of the objectives is to be able to incorporate new technologies like transition from legacy systems, 3G, 4G, to modern ones like 5G, 6G, moving from coaxial cables to optic fiber cables, and new technologies. If you are not able to do that, then business may likely be in trouble in the near future. So we must also be able to plan to adopt future-proof technologies like SDN, NFV. We all know what they are: network function visualization and what it does. We must, be able to plan a system that can, make use of edge and fog computing in the future. If not, when all these services are fully developed and in use, then the users will avoid your network. So you must be able to look up to these future technologies and see how you plan to incorporate them. Also, you have to optimize cost efficiency by investing in infrastructure with long-term returns by reducing need for frequent, costly upgrades and overhauls. Your planning must be able to meet regulatory and environmental requirements. That is, they must comply with government policies and international standards. They must incorporate sustainability and energy efficiency parameters. Else, you will be running your cost of operation will be very high. You must also plan a system that will improve quality of service by ensuring uninterrupted, high-speed, and reliable communications. Now, when you are doing your long-term planning, there are basically components of that you must consider. One is the transmission technologies. Is it going to be fiber optics? Is it going to be through satellite communication? Is it going to be through microwave communications? Each of these has its own advantage and its own disadvantage. For instance, if you're making use of satellite communications, you'll be sure that there will be small delays introduced between the transmitting and the receiving point. If you are making use of microwave, then you must be able to roll out repeater stations after every about 48 kilometers to avoid deep fadings and the effect of water in the atmosphere. So whichever of these technologies, you have to weigh the pros and cons and do a link budget to see which will be the best services to have an uninterrupted transmission. Also, you have to consider the switching and routing architectures. You have to also look at the spectrum management to see where you have the radio windows to operate your services with minimal degradation and distortions of signals. You also have to plan your coverage and capacity expansion. Then, core and access network designs. You must be able to plan for integration with emerging digital services, and you must be able to plan for a trade-off between capital and operational expenditures. So if you do that, then you now move to short-term planning. But before you do that, saying that in this your long-term planning, as a telecom operator, you must perform this long-term planning by projecting mobile data demand over the next 15 years. When you do that, you will now come up with a decision: where do I make the greatest investment? Is this to invest in 5G based stations? Is this to expand my fiber optic backhaul? Is it for me to reserve some of my spectrum for 6G rollout? And you must build cloud native network architecture, because most of the things being done now is moving to cloud computing. Then we move to short-term or growth planning. Telecommunications network short-term planning refers to the process of designing and optimizing network operations and resources to meet immediate or near future demands, typically within a time frame of few weeks to a maximum of 1 year. Key aspects of short-term planning in telecom networks include traffic forecasting, that is, predicting short-time variations in network usage, like on daily basis, weekly basis, monthly basis, adjusting capacity to handle expected traffic peaks. For instance, if in your vicinity the World Cup is going to be played next month, we see that it is expected that the traffic, telecom traffic, will increase within that vicinity while that tournament lasts. So you should be able to anticipate and forecast the number of inflow of telecom users and be able to provide a quick measure for them to be able to enjoy communications while the tournament lasts. That is traffic forecasting in a short-term period. Two, resource allocation. So you must assign bandwidth, frequencies, and routing paths for current or near future usage. Managing available network elements efficiently, like having routers and switches and mobile-based stations that can easily be deployed where there is traffic peaks to absorb congestion. Then you have to put up maintenance schedule when you are planning your short term. So planning routine maintenance activities without disrupting the service quality must form part of your short-term plan. You must be able to ensure network reliability through timely upgrades and inspections. You must be able to manage capacity by monitoring load levels and scaling up or down network elements based on demands, and also avoiding network congestion and service degradation. You must look for way to manage operational adjustments, and you do this by implementing new service plans or adjusting existing ones based on market designs. You must be able to deploy temporal infrastructure. For example, mention when events or there are emergencies, if there is, like we have disasters and people are moved from their location to another place, your system must be able to deploy temporary infrastructure to accommodate those people in that camp. So you must also be able to optimize your quality of service by ensuring your service performance. When we talk of service performance, you must make sure that the latency, the efficiency or the throughput, the reliability remains very high. If not, people will migrate out from your network to another network. You also must make real-time adjustments as the need arises. Now, what are the objectives of this short-term telecom network planning? We say, one, you must be able to maintain service quality and reliability at all times. You must optimize the use of existing infrastructure. You must minimize operational cost. rapidly respond to changes in user demand or network conditions. You must be able to prepare for seasonal or event-based demand spikes. What do we mean by this? If, annually people move to a particular stadium for one annual event, then you have to be prepared that during that time every year to get some, improved facilities to be able to take that demand spike. Any short-term plan should be reviewed continuously and amended as necessary to meet spontaneous system demand. Now, in this strategy planning, you must be able to revise plans to meet new service requirements so that this may be necessitated by a decision to introduce new facilities and techniques such as moving to asynchronous transfer mode of transmission, synchronous optical network, accommodate internet services, and voice over internet protocol, and so on and so forth. The general requirements of the planner are usually and visually independent of whether the entire network or a single component of the network is considered. The fundamental data required can be listed as follows. 1. Traffic forecast, plant details, network demands. So in this planning, the traffic forecast, like we have seen, that the short-term traffic forecasting refers to the prediction of network demand, traffic load, resource requirements over a relatively short period of time. The main goal is to ensure that the network can efficiently handle immediate or upcoming changes in usage without degradation of service quality. It ensures the network remains responsive and efficient by predicting immediate future demands and adapting accordingly, thereby enhancing reliability, performance, and user satisfaction. Now, what are the key aspects of short-term forecasting in telecom design? They include: 1. Time horizon. Usually covers hours, days, or up to a few months, focused on immediate operational needs rather than the long-term planning. What is the purpose? The purpose is to optimize network resources allocation like bandwidth and channels, maintain quality of service by predicting spikes or dips in usage, and support maintenance scheduling and dynamic load balancing. Purpose must be able to help with traffic routing decisions in near real time. Must look at the data inputs by looking at the historical traffic data, example, call volumes, data usage, user behavior patterns like time of the day usage, event-driven factors like holidays, live broadcasts, and weather. Now, if we look at this more critically, when we talk of historical data traffic, we will see that if you have, the population of a place and see that the population is made up of aged people, then there is likelihood that when they make calls, they hold the call for a long time. Maybe talking to their grandchildren, talking to their children, it will usually drag for about 30 minutes or more. When you get to the university environment, you will see that call durations will be maybe maximum 5 minutes. Only very few calls will, exceed 5 minutes. It means then that every 5 minutes, the channel is available for another person to use. So with this historical background of the place, you'll be able to know, do you deploy facilities that holds long and few calls, or facilities that we make use of short calls, and always every few minutes the channel is available for another person to use. Also, you have to look at the user behavior. What time of the day? If it is in transportation, you talk of busy hour. In telecoms, we also talk about busy hour. There are times of the day that calls peak. There are times of the day the calls drop. So it becomes a statistical analysis between provision of facilities to handle these peak hours or busy hours. Of course, the event-driven factors is like if you have a holiday resort, you will see that during holidays, there will be demand for facilities within that area. But you don't go on and design a system that gives the maximum for that place. Then during non-holidays period, the systems will lie idle. So, say that data input when you are doing your short-term planning is very, very necessary. Now, these are some of the forecasting techniques that you may have to get to know to be able to handle this very well. So that have to do time series analysis, like these models can help you do that. You have to do machine learning. Regression analysis can help you do that. You have to also, learn statistical smoothing methods, simulation modeling for scenario testing. So all these techniques are available for you to do the forecasting. So you also have to use some cases in telecom design, like capacity planning for peak hours, provisioning temporary resources during events. We mentioned that, optimizing handoff strategies in mobile networks. We want you to, if you subscribe to my channel, as I go on in my subsequent lectures to talk about, mobile and cellular telephony, you will see the strategies available for handing off from one base location to another base location. Also, you must be able to do some energy management by dynamically powering down unused equipment. So, finally, we'll be looking at plant details. Before you prepare a plan, the engineer must be fully aware of the technical and other parameters of the switching, signaling, and transmission equipment in the existing and planned network, and the internetworking constraints of that or those equipment. You must also be aware of such details as plans for replacement of obsolete equipment and the exhaustion dates of accommodation, cable ducts, and so on and so forth. Cost data for all new plants is also required, preferably in terms of both fixed cost and annual charges, to enable economic comparison to be made. Therefore, these cost details can frequently be transposed into graphical or tabular form for ease of use to show the choice of system appropriate to meet the traffic growth rate expected. Thank you for listening. Our next lecture will be on Telecommunications Network Planning Standards. And in that planning standards, we cover numbering plans, transmission plan, charging plan, routing plan, signaling plan, and how this will help in good grade of service and help in the design. Thank you for your time listening to this lecture.